Hello learners, with you here is Mwalimu Zakaria. Welcome to my YouTube channel Math Chemistry. This YouTube I meant to help students in major subjects that mostly disturb them, that is mathematics and chemistry, and also with extra advantage of biology. This is my contact, both phone number and email. Also, I do tuitions, both physical and online tuition. You can get physical tuition if you live in Nairobi, and online tuition if you live outside Nairobi, if you live in outside the country, wherever place that you are. I do teach Kenya system and British system, that is IGCSE. Welcome. Today we have chemistry form 4, that is form 4 work. The first topic, that is chemistry of acids, bases, and salts. We have here lesson 1. Let's say now how we define acid and base from form 1 in the topic of acid, base, and indicator. 1. Acid may be defined as substance that turn blue litmus paper to red. Always litmus paper is an indicator which tests the acidity or basicity of a substance. For acid, it turns blue litmus paper to red. Also, acid reacts with metal to form salt and hydrogen gas. We can have the general equation. If you remember the general equation, acid react with the metal to produce salt and hydrogen gas. We can have an example of equation. Let's say we have metal sodium. We have sodium. Let's say it reacts with hydrochloric acid, that is an acid that we have. What does it form? This is dilute acid, which is aqueous. It forms salt. Our salt here we have sodium chloride plus hydrogen gas. If we balance here, sodium is 1, hydrogen here is 1, chlorine is 1, hydrogen here it is 1, hydrogen is 2. So let's balance here 2. Chlorine is affected again, chlorine is 2, chlorine is 1, chlorine here is 2 again, sodium is affected, sodium is 2 again there. That is now acid. It reacts with the metal to form salt and hydrogen gas, and we see the reaction. Secondly, also acids reacts with the base to form salt and water. If you remember the general equation, if acid react with a base, it forms salt and water. So let's say we have equation. Let's say we have sodium hydroxide. Let's say it reacts with the sulfuric 6 acid, which is dilute acid, aqueous. It forms salt. Which salt do we have here? Let's say we have sodium sulfate, the salt that it forms. Sodium sulfate plus water, that is liquid. If we balance, sodium here is 1, sodium is 2. I balance by 2. Let's go to sulfur. Sulfur is 1, balance. We go to hydrogen, hydrogen 2 again. The reactant side 4. Here it is only 2. We put here 2. Let's see oxygen. Oxygen here is 4 with a 2. Reactant side oxygen 6. Here it is 4, 2. It is self-balanced. Thirdly, acid react with metal carbonate to form salt, carbon dioxide, and water. If we refer to the general equation, if acid react with the metal carbonate, the reaction that we see, metal carbonate, it forms what? It forms salt plus what? Carbon dioxide, and what? And water. And water. So it forms salt, carbon dioxide, and water. Let's say we take metal carbonate, let's take sodium carbonate. Let's say we have sodium carbonate. It reacts with acid, let's say nitric 5 acid. What does it form? It forms metal nitrate, which is metal nitrate, sodium nitrate, plus carbon 4 oxide and water, aqueous, gas, and liquid. Let's balance. Sodium is 2, sodium is 1. How can I balance? I put here 2. Nitrogen is 2, nitrogen is 1. I put here 2. Carbon is 1, carbon is 1. Balanced. Let's go for hydrogen. Hydrogen 2, also balanced. Lastly, oxygen 3, and that is 3 times 2, 6, plus 3, 9. 3 times 2, 6, plus 2, 8, plus 1, 9. It is balanced. That is now the acid. These are the 3 major reactions that we have in high school. That's the reaction of metal with acid, acid with base, acid with metal carbonate. These are major chemical reactions that we have in high school. Secondly, we have base. Let's say a base. Base is a substance that turns red litmus paper to blue. Always, litmus paper is an indicator. It tests the basicity of substance. So when you take a red litmus paper is dipped in solution of base, it turns to blue, and that it tests it being a base. Also, bases reacts with acid to form salt and water. Remember, in this reaction here we have, if we react acid and base, we form salt and water. That is the base react with acid. That's now the definition of base and acid, the way that we referred when we were Form 1. Let's see now definition in this topic. Let's see definition proposed by this person who is called Arrhenius, the person who brought this idea. We have Arrhenius' definition of acid and bases. How does Arrhenius define acid? Arrhenius referred acid as is a substance that dissociates or dissolves in water to produce many hydrogen ion as the only positive ion. So meaning here we have hydrogen ion, and the hydrogen ion that is produced there, it is positive. So it's anything that dissociate means to dissolve in water to produce hydrogen ion as the only positive charge. So the charge that it has, it is positive. Let's say now some example that we can have. Let's say I have hydrochloric acid. Example, I have hydrochloric acid. Hydrochloric acid, let me say it is HCl. It dissociates in water, H2O, to form what? To produce hydrogen ion and chloride ion. So the acid dissociated or dissolved in water to produce the hydrogen ion. So this is the hydrogen ion that I refer to it. Let's say another example. Let me say I have sulfuric acid. Let's say another one, sulfuric 6 acid. That is H2SO4. It dissociates in water to form hydrogen ion and sulfate ion. Here I can balance by 2. So it's hydrogen ion that I'm producing there. So Arrhenius proposed that acid is a substance that dissociates or dissolves in water to produce hydrogen ion. That is now Arrhenius, the way he defined acid. Let's see now how Arrhenius defined base. So we have here base. So Arrhenius referred base as substance that dissociate in water to produce or to form hydroxide ion as the only negative ion. Remember, hydroxide ion is written OH negative. So base, it dissociates in water. It dissolves in water to produce hydroxide ion. And the hydroxide ion that is produced, it is negative. So as the only negative ion. Let's see example of it. Let's say we have sodium hydroxide. If I have sodium hydroxide, let me say sodium hydroxide, it dissociates in water to form sodium ion and hydroxide ion. So hydroxide ion is produced as the only negative charge. So that substance, when it dissociates in water, that produce hydroxide ion is what we refer as a base. And this is the definition of Arrhenius, the way he referred acid and base to it. Acid and base to it. Let's see our second way that we can define acid, and this is brought by a person called Bronsted-Lowry. So we have Bronsted-Lowry definition of acid and base. How does Bronsted refer acid? He said acid is a proton donor. He referred acid as proton donor. What do we mean proton donor? It means it donates hydrogen ion to other substance. So the substance which is being donated, it is a proton, and that proton, it is hydrogen. So it donates hydrogen ion to other substance. A base referred as proton acceptor, meaning it receives hydrogen from other substance. So always, if hydrogen is proton donor, one thing you should know here, that the number of hydrogen reduces, meaning it donates, it gives to another substance. So meaning the number of hydrogen that it has reduces. If we have a base, it is acceptor, meaning its number of hydrogen increases. So in a base, a proton acceptor, so it receives hydrogen ion from other substance, meaning the number of hydrogen increases. Let's see simple question. Study the question below, giving a reason. Identify the acids and bases. Ammonia reacting with water to form ammonium ion and hydroxide ion. So here we have that arrow. So what is the acid? For us to identify the acid, we look down where the number of hydrogen reduces. Ammonia number of hydrogen 4, number of hydrogen ammonia is 3, ammonium the number of hydrogen 4. That is, number of hydrogen increases. It's not acid. Which one is the acid? The one which the number of hydrogen reduces. Water, the number of hydrogen here is 2. It forms hydroxide ion, where the number of hydrogen here is 1. So our acid is water. Why? Its number of hydrogen ion reduces. So the acid that we have here, it is water. Let's see the reason. Why is it water? Water donates hydrogen ion to ammonia to form ammonium ion, because acid is a proton donor. Why? Its number of hydrogen get reduced. So we say water donates hydrogen ion to ammonia to form ammonium ion, Let's see a base. The base is the one where the number of hydrogen increases. Which one? Ammonia here, the number of hydrogen is 3, and ammonium, the number of hydrogen ion here is 4. So what is our base? Our base is ammonia. Okay, what is the reason? A base is a proton acceptor, meaning it receives hydrogen ion, meaning the number of hydrogen here increases. So it receives ammonia gas receives hydrogen ion to form ammonium ion. Okay, let's see question 2. When potassium hydrogen sulfate is dissolved in water, sulfate ions are produced from hydrogen sulfate ions according to the equilibrium below. So this one is potassium hydrogen sulfate. So we have hydrogen sulfate ion, it dissociates in water to form hydroxonium ion and sulfate ion. So giving a reason, which one acts as acid? What do you know about acid? Is a proton donor, the number of hydrogen reduces. So which one the number of hydrogen reduces here? Hydrogen sulfate has hydrogen, it forms sulfate. Hydrogen is reducing. This one is 2 hydrogen, it forms 3 hydrogen. The number of hydrogen increases. So which one is the acid? The one which its number of hydrogen get reduced. Which one now is hydrogen sulfate? That is potassium hydrogen sulfate. So what is our acid? Potassium hydrogen sulfate. So potassium hydrogen sulfate is our acid. Why is it our acid? Acid is a proton donor, so it donates, meaning it donates hydrogen ion to where? To water. It's donating hydrogen ion to water. To form what? It has formed hydroxonium ion. To form hydroxonium ion. Which one is our base? Base is the one at which the number of hydrogen increases. So here water, number of hydrogen is 2, here the number of hydrogen is 3. So meaning water is our base. Why? Because it receives hydrogen ion to form hydroxonium ion. So meaning it receives proton acceptor. It receives hydrogen ion from where? From hydrogen ion to form what? To form hydroxonium ion. The next, let's say strength of acid. What do we mean strength of acid? That is ability. The acid has the strength, the ability. Is the acid strong or weak? Is the base strong or weak? So the strength of acids and bases, these are strengths of acid and bases, depend on 3 things or 3 factors. Also 4. Let me not say 3. 1, it is degree of dissociation. B, it is the pH. C, it is electrical conductivity. And D, if I add, that is the chemical reaction. Also chemical reaction affects the strength of acid. Let's see the first one, that is the degree of dissociation. Yeah, here we have the chemical reaction. The first one, let's see degree of dissociation. An acid or base can either be strong or weak depending on the degree of dissociation in water, meaning on the ability to dissolve in water, to dissociate, to dissolve in water. And let's see, what is a strong acid or weak acid? We have a strong acid. Is a type of acid that completely, or you can say fully, or you can say wholly dissociate or dissolves in water to produce many or more hydrogen ion as the only positive ion. So a strong acid, it fully or completely dissolves in water and it produces many hydrogen ion. Example of it, nitric 5 acid, sulfuric 6 acid, and hydrochloric acid. Let's say a weak acid is a type of acid that partially dissociate in water. Is the opposite of strong acid. This one completely dissociate, this one partially dissociate in water. It produces many hydrogen ion, it produces few hydrogen ion. Example of weak acids, that's weak carbonic acid, we have ethanoic acid, we have oxalic acid, we have methanoic acid, and so on and so forth. B, let's say now a base. We have seen strong acid and weak acid on the ability to dissolve in water and on the ability to dissociate in water. What is a strong base or weak base? Strong base. This is a type of base that completely or fully or wholly dissociate in water to produce many hydroxide ion. So it dissociates fully or completely in water. Example, sodium hydroxide, potassium hydroxide. Weak base, this one is the opposite of a strong base. This one completely dissociate in water, this one partially dissociate in water. This one produce many hydroxide ion, this one produce less or few hydroxide ion. Example of weak base, ammonia solution, calcium hydroxide, Woosh ash solution, magnesium hydroxide, and so on. That is our lesson for today. Here we have self-trial questions. Try to do this question and share the answers in the comment section. Welcome all.